Thank you for being here this morning. I'm Ivan Gentile. I'm at IFAB office in the center of Bologna. A bit of a cloudy day today. Hopefully the sun will come in time. I will present you today a guide about prompt engineering. Let's see what actually we're gonna cover today. So we have three main points to approach. The first one is why LLMs work. Here, so the goal is actually to talk about prompt engineering, but this will be done at the end. Before, I would like to demystify a bit what AI means, what a large language model means in this context. And so we're going to actually spend some time kind of understanding how this.
Ok, questa è quella che ti dà
How these machines work, but still in an easy way, no worries. It's not going to be highly technical presentation. And then after that, we were going to try to kind of see what is a prompt from the perspective of these LLMs. And then at the end, we're actually going to have quite a bit of examples regarding how to talk to these AIs. So we start with actually what is generative AI. So generative AI is actually a broad field. The thing that, let's say, make the field coherent is the fact that when we deal with this generative AI, we're actually going to create new data, generate new data upon user interaction. And this is a substantial difference that all of us need to have ingrained regarding what changes when I ask a question to ChatGPT with respect to when I ask a question to Google, right? If I ask to Google, I usually find things that up until now have been written by humans. This is going to change in the evolution of the internet in the next few years, thanks to these large language models. While if I ask to ChatGPT a question, I actually get a new response that probably nobody saw in that way. And there are many fields in generative AI. We have also models that generate images, video, and music. These tend to be different models. And then instead we have models that generate language, which is the focus of today. And within this focus, within this presentation, we're going to basically focus on this. So to start, I would like to demystify this autoregressive word. It's usually like a difficult, kind of scary word, but it's not. The concept is easy. Like the fact is, basically, autoregressive model generates things. In this case, in the case of LLMs, tokens or words. We're going to assume things one step at a time. Okay. When we generate when we start this process, we see that the process is iterative, where the output of a given step is dependent upon the previous steps. And we're going to see, we're going to try to simulate what we mean with the image on the left that we have here. So to start, we actually have to define not large language model, but language model itself. And this is a field that has been on for more than around 100 years, I would say. And there are different approaches to constructing language models. But let's say that many of them, not all, but many of them have this concept of trying to connect a computational model to a probability distribution, where the basic elements are the sequences of words. And we can imagine these words, in this case, if we have on the left, I visited the city of, adding a language model to this sequence of words will mean obtaining this probability distribution that we see on the right, where the most probable word is Rome and the least probable is New York. And the fact is that the language model tries to predict the probabilities based on patterns learned from data. We're going to see now. So essentially, when we talk about language models or now large language models, these are these super large, we reach very, very scales. Like if we talk about number of parameters, the same as number of stars in the galaxies, 100 billions parameter. What we try to do essentially is tries to intelligently continue whatever text is fed to them by consulting the probability distribution. Now we're going to go through an example iteratively to demystify the autoregressive process, the autoregressive word, and actually understand how this model works. It seems simple, but like I would like you to stick with it. So let's say that I'm the emoji there, and I ask the LLM, hello LLM, what's the best thing about AI? I'm starting with the iterative process. I'm at t equals 0. And then I see the LLM is there and is reflecting. Let's say we can set up this analogy that is starting to think and is reasoning. Given the text I received so far, what should be the next word? It reasons. The text is all the text, like all the sentence that I gave to it. And then it output there. And this is the output of step T0. And then at step T1, we have that not only it receives my own sentence, but it also gets its own output. So it asks me a question, and the first output it gave, so there. Then it reasons again, and the output of step T1 is the best. And this process continues iteratively. So again, at the step T2, it takes not only my question, but also the best. And this, if we continue, let's say, in this case, 9 words, so step T9, we have this table where it outputted the best thing about AI is its ability to, and then if we stop, basically we'll have this probability distribution with all the words that it can predict and the probability assigned to each word. I give like 2 seconds to let you think which word will select the LLM now. So let's think between the 5 learn, predict, make, understand, which one the LLM will actually choose. So you might have guessed learn, but in this case it actually outputs understanding. Why this? So basically there is this parameter called the temperature that is responsible for not selecting always the most probable word, in this case learn, but also one of the, let's say, still highly probable but not most probable word, in this case understand. And this is a very important parameter, and it also gives us an insight on why if I ask the same questions to these models twice, I don't get the same answer. I get slightly different answer. All right, so we have basically covered what is a prompt. We covered what is an iterative model, what is a language model, what is a large language model, and why like it has this, let's say, stochastic element, randomicity attached to it. We now want to see a bit more in detail. Now we go through what is a prompt. So to start, this I will not have time to cover, but and my head of education always tell me it's not a proper slide to show, but I like to show it anyway, because I think it's very important to see the diagram on the right at least once. This is actually in 2017, let's say, there is a paper has been out called Attention is All You Need, where this architecture called the transformer has been introduced. And this is basically was the seed that started this whole kickstart in AI, funds and funds, billions and billions. But okay, let's jump not to the highly technical stuff, just one component of this machine called the tokenizer. So in the example before, we saw that actually the model was trying to output words. What actually happens with the models that we use, like ChatGPT and so on, we not use words, but we use tokens, okay? And what are tokens? We're going to see it in an example, but essentially these are the product of this component called the tokenizer, which takes our input text, it transforms it, and then it basically prepares the table for the whole other machine to actually go on and make prediction and calculate the right probabilities. We're going to now see a few examples of the tokenizer and why this is needed. These are all taken from this app on the bottom left, which you can check out and play yourself if you want to. And we're seeing here like Okay, let's explain what you're seeing here. On the left, it's me that I write something I want. On the right, I have the model on the top. Okay, in this case, we're seeing how GPT-4o interprets what I wrote. The total number of tokens. Below, we see the token colored, and we see the numbers. These numbers, they're essentially what the model speak, okay? We use text, we speak text and stuff. Machines tend to speak numbers, and the numbers that the LLMs speak are actually these tokens, okay? And so we see that all you need is log, easy, five tokens, kind of example. Actually, you might think, okay, so if I write to the LLM, all you need is log, it doesn't matter if I write caps, if I don't write caps, or like if I go one cap, one not, if the meaning is the same, then the tokens are the same. And this is actually a mistake, another mistake. As we see here, from the right, we see that we have a certain kind of tokens. So for example, all with no caps, we have is the token number 586, while all with caps is the number 7011. Okay? And then we see that if we have all Al plus big L, it's actually the token 2348 and the 23. We're going to see later why this matters. For now, just take my word for it, like this matters, like if you use caps or no caps. And then we're also seeing like that if we have different models, we have different tokenizer and hence different tokens. Again, here, everything no caps, so you need this log. We have on the right GPT-4o, on the left DeepSeek AI. And we see that DeepSeek R1 actually uses the number 578 for all instead of the number 586, and similar for the rest. So the token count is the same, but actually tokens are a bit different, okay? This is dependent upon the training. This is important. No, you might have heard about DeepSeek, Chinese model. They trained it in China. They have a certain kind of behavior behind it. And let's say that it matters, like not only you can control some sensor content with it, but also like there are implications behind where you train and how you train your model. Okay, so we saw the caps, no caps, we saw different models, we see also the different language imply different token. Again, it's not about the meaning, so it's like it's not that the LLM does not understand the meaning that we tell them, right? They get the text and the text becomes number and then reason upon these numbers. So we need to make sure, like in the next 15 minutes, we're going to try to make sure that the numbers we gave them are the numbers they want to see in order, or I want them to see in order to respond to me. Here we see different language in Italian on the left, different tokens. What happens here? The same example, but with R1, because it brings up this phenomenon where if I have the language like a not very common language, Italian is still pretty complex. It has ample resources to train LLMs. Okay, so here we see it's not in GPT-4 didn't make a difference. Here we see that DeepSeek chooses to split Amore in 2 tokens rather than 1. Okay, and this increases the token number. And you say, okay, well, six tokens and then 5 doesn't matter. Well, it actually matters a lot if you think about longer text input. Here we have the treaty establishing the European Coal and Steel Community. Same content taken from the European Union page. We see how another model, Google, Gamma, 7 billion. This is a small model. So also the size of the model often also impact not only the research capabilities, but also the token is influenced. We see that in English it's only 2,000 tokens. In Italian it's 2,700. In Finnish is 3,400. So like big difference, almost double the amount of tokens in Finnish compared to English. Why does it matter? Well, it matters because essentially we have a limited amount of token that we can give the LLM in a given prompt, in a given use. And what is this maximum number of tokens? This is called the context length. And this is the maximum of what the LLM can see and process at once. The short-term memory analysis, that's something that I use often, is like, I like how the human is like this graph in this slide, but in any case, the human memory is like, we have, I've been trained upon, like, I don't know, I read the Promessi Sposi, or I read the Divine Comedy by Dante. I don't remember everything. I know more or less the general theme. If I read a specific chapter, then it's in my short-term memory, and I can recall it better. Similar for the LLM. The LLM has been trained on a lot, like almost all the whole internet, okay? Almost the text that is on the internet, the large ones. But this is sort of like, it's kind of in the background knowledge. If I want to refresh their knowledge, it's good that I give them like things in their context in order to build up this. And this matters a lot also for business. We see that, like, so the context window size is an element dependent upon the LLMs, and like based on the kind of application that I use, the context window must be larger or smaller. In general, larger context implies higher cost and also higher processing time. Okay, so we're building up. We're reaching. We saw more or less what an LLM is, how it speaks number rather than text. And now we want to see like actually how to talk with them in a proper way. So in order to, this is usually called the field of prompt engineering. And it is actually the practice of designing and optimizing input to get the best possible outputs from these LLMs. In general, I like to show this kind of arrow, going from the least important things that I need to specify in a prompt to the LLM to the more option. So the most important is the task. Like, I clearly need to tell him what I wanted to do, but it's also very important that I give him some context. I usually specify, like, I have many hats. Like in my foundation, sometimes I need to deal with database. Other times I need to deal with machine learning models. If I deal with machine learning models, I tell them that I'm more a senior data scientist. If I deal with database, I tell them that I'm more of a data engineer. This is an example. If I need to write a presentation, I tell them that I'm a public speaker. Depends, so I can give him context. It's good if I give him examples. Examples means that actually demonstrate them how I want the task to be performed. This is, if it's something that I'm doing many times, I might record what I try to do, save it in a Word file, in a text file somewhere, and then have it there in order to be able to paste it back into the context of the LLM together with my question in order to boost performance. We're going to see this a bit later. Then I can tell him to act as a certain kind of person, so give him a persona. I can tell him to structure the output in a certain way. I can tell him to use a certain kind of tone. So a practical example of this is this. We can see it in this slide. So we see if I just tell him, help me create a marketing strategy, like I don't give him enough context, I haven't given him the persona, I didn't provide enough information to the LLM in order to get the good reasoning and the good output that I want, right? So in order to do this, I can try to switch and I build up a full prompt and I tell him, I need help developing a market strategy for our product. It's a new eco-friendly smartphone accessory for millennials and Gen Z. Include 5 marketing channels, act as experienced marketing professional with eco-friendly expertise, very important, the eco-friendly expertise, and then structure with market analysis, target audience, professional, but innovative is the tone, okay? And we see from the more important to the more optional. Okay, so I told you this kind of prompt engineering introduction. You will tell, okay, now I need to every time write all these things and stuff. I introduce you to probably one one tool that will change how you act, that you do it, how you use LLMs, and this is what I call meta prompting. I don't know if it's but let's see an example of a meta prompt. So in this case, we see I have my message on the top, no? I want to explain to you meta prompting. I want the LLM to explain it to you. And I could just type, please explain meta prompting, the technique of asking an LLM to improve your prompt. But I can also do this. I can go and ask, please improve this prompt. So I tell him to improve the prompt, and he gave me the full answer, like, okay, from like to understand meta prompting in depth, include a clear definition of meta prompting, the specific benefits and use cases, practical example, and so on. You see that he gave me a big prompt, like a more, like a better prompt to ask the LLM, still like quite fast, no? And we can see an example of like how the questions, the answers to my question will change in this scenario. Here we see the answer from explain meta prompting. And here we see, I will not read it for sake of time, but we see still quite a good response. This is Claude, so let's see what I get from asking the improve the prompt. So I paste what the LLM gave into as a question, as a prompt, and it gives me, well, still the first the start. It goes on, practical example, write a blog, like we see original prompt, meta prompt. It goes on and on again, like it gave me all of these, like this is a different visualization, but just to, like it was a very, very long answer that I got from this kind of meta prompt example. I was surprised myself at the length of this answer, but this is to let you reason, like there is quite a bit of substantial difference from this and this. And also, I do not always want to go for this. It's not that I meta prompt everything that I ask to the LLM, but if I'm doing an important task or I'm at the start of what I call this collaborative process, working on an LLM on a task, it's good to do it. It's good to do it. Okay, and so this brings up this other example. I can anticipate this as well. The other thing that you need to know when dealing with LLMs is you need to feel free to abuse copy and paste, because we have this thing about short-term memory. It's good if I read again La Divina Commedia, or in this case, I Promessi Sposi. Let's say an example. Here I give a prompt to ChatGPT for, I think, it's like summarize I Promessi Sposi first chapter in one sentence. It tells me that the novel introduces the main character Lenzo and Lucia, two young lovers, beginning with them. Okay, not bad. Then what can I do? I can go online for the first chapter of the Promessi Sposi, paste it into the context, and I see still ask the same question, summarize the chapter in one sentence. And I see that instead of giving this kind of generic answer, it actually describes, the narrator describes the serene landscape around Lake Como, introduces Donna Boeing, and depicts his encounter with two intimidating bravi. Okay, higher quality answer. And this is something I can do with, okay, this is a book, but maybe you're dealing with some kind of companies online, they have information on the website, you can copy and paste from the website and try to get this, this is also true for images. Here I will go very quick. I will not, here I want to generate an image of a table. It gives me this kind of table, still pretty neat. I really like the floral composition of the center. But if I give him some context, in this case I gave him iPhone images, okay, and ask him to generate the same table, I see that it generates the Apple table. And I think it's quite like, it's not even so far from what they will produce. And this also, like, there are general information to keep in mind regarding, we'll not go into it in a bit. Okay, this is regarding prompting in general. Another thing, so now, like, with all these files within the LLM world, the understanding is that they are able to use tools. We're going to see very quickly what these tools are, but it's good to be informed that they have tools available and that they can use and which we might not know. So if I go on the screen page of ChatGPT, which is the most popular, first of all, like be mindful that on the up left, we have like which model we are using. GPT 4.5 is the new version, but you can select which model are the best. I will not talk about reasoning models here, which are kind of a bit of different paradigms, the same line. But we also have all these buttons, like in the taskbar, where I can explicitly ask the LLM to look for content on the internet, so that maybe can avoid hallucination, gives me then the sources from that. There is this tool, deep research, which is very important. I mean, I think it's a very, very cool example here. I'm specific, like it's a specific question to data science use case, but he has to compare two frameworks. And basically what he did is he went on the internet, it took 6 minutes and 6 minutes to find all the sources that it needed. It found 38 sources from the internet that were relevant to this question, and then it compiled it together in a single report. And this is a very useful feature you can try out. The GPT is also able to use the Python interpreter. There are many things to check out. And then there are also like with the Claude, they can also kind of generate these graphics. Some of them I've used it during this presentation. What you should always be mindful of, so far only roses, no, we always be mindful of hallucination. I don't know, maybe for the experience here, I don't know if you realized it. When I asked him to generate this graphic, it included the example, but it's not what I meant with the examples here. When we want to include example, when we talk about example in prompt engineering, what we actually mean is including it ourselves. So technically, this is called the few-shot prompting. Complicated to just say, okay, include some example of a question in response to this question. And this enables what is called in-context learning, which is a bit different branch. Okay, to close, we're at the 30 minutes mark. So another thing that I want to give you is this perspective. You can talk with these LLMs both as tool and as person. You should be mindful. So as a tool, you can try to use a certain information, so you can understand that they need to use these numbers, like in order to process stuff, and you can set up out the quality of the numbers very soon. And there are certain tricks also from prompt engineering that I tell you now. One of the most important tricks when using non-reasoning models, so like not O1, this kind of, but the ChatGPT, is adding this kind of think step by step. If you add the think step by step, this is something that I always say when I was in elementary school, like I was quick at doing math, and I was always jumping ahead the steps, right? I will not do everything, and then my teacher will say, okay, don't skip steps because it's important that you do it, you write it, but I didn't like to write, so I will jump to the solution. But the harder the mathematics gets, the easier it's for you to lose the science when you skip the steps. So you learn that you need to write all the steps. And this is the same for the LLMs. Like you don't want them to skip ahead too much. You want them to actually reason one step at a time in order to have, again, to remember the iterative process. Like if you output a reasoning at a certain step, it will become the context for the future response, and therefore it will have better, like shorter memory in order to reach the right conclusion. The things that I said is an important part. Use the limiters is another thing. Like I give you an example here. I come back a little bit. In this case here, very simple. Like I don't know if you see here, when I paste the message posi, I add these triple quotes there. And this makes a little difference, but it can, let's say, sort of changes a bit the quality of the. This is what is also very important is to provide more information than you think. It's like, as I told you, copy and paste. Ask for a structured output if you need it. Break down tasks. Again, don't ask always for going for the moon. Like you first try to build a rocket and then go to the moon, and then provide examples. We already talked. And then the other side is instead the part that, like, when we deal with these things, like let's engage in collaborative process. Okay, you have like to think about it. So like I'm sort of when I code, I'm a data science. When I code, I'm sort of developer. I'm a developer, but I'm also a product manager in the same time. You know, I need to think about the feature that my products need to have, and I can do this as if I would do it as a product manager, but with the developer. Like I can think about engaging in conversation with a person, ask opinions about of that person that might be different from me, different from my ideas and so on. I can test the knowledge on the subject. If I am doing a very special, like niche kind of use case, it might happen that the LLM doesn't have enough training data to actually solve the task. If I do an easy question, I can see that it's already struggling. I don't go for the very, very niche. Be curious. This is most important, and then try to enjoy the conversation, because I think it's also to have in our pockets, so also pockets and laptops.